All right, today we start at this number 25.
Okay.
F is the function given by the equation y equals square root x minus 1. What is the value of approximation of f 3.8? Okay, 3.8. But to approximate this value, we're going to use line tangent to this graph, tangent line. For example, over here, this one varies this one. I'm going to get very similar to the graph of this one. Square root x minus 1 is when x equals 0, y is negative. We start from here, okay? That's the square root x minus 1 graph. So we're going to find, okay, the value of y when x equals 3.8. 3.8. Okay, this value, okay, the actual value is how much? Actual value is what it is? Square root 3.8 minus 1, right? That is the actual value. But because this is the square root 3.8, it's not a special number, right? That's not the square numbers there. So that's why we're going to use, okay, x is a 4 there. X is a 4. Because what? When x is a 4, okay, square root 4 is how much? Square root 4 is a 2, right? Easily we can
Yeah.
find, okay? So at this point, we make a tangent line there. Using this line, we're going to find, okay, this value, f of 3.8, approximation value. This was the real value, so better use, okay, polynomial, right? Approximation, I'm going to use 3.8, okay? So this is now approximation, okay, from here, right, up to here. Are you okay
Yeah.
with this? On this line. But this is a little greater than actual value, okay? So to find this one, we're gonna find the equation of tangent, right? The equation of a tangent first. So we have a point over here. When x is 4, what is y? When x is 4, what is y? 4 minus 1 is 1, right? Is it
Yeah.
okay? Okay. This point is when x is 4, y is 1. But we need to find the slope. How can we find the slope? Derivative, right? Derivative.
Yeah.
So y equals square root x is what? X to the 1 half and minus 1. So dy dx, okay? So you can use the y prime dy dx, same this. Put this number 1 over 2 and move to the front to 1 over 2. X and minus 1 is negative 1 over 2. The next term is constant. The derivative of constant is 0. Okay? But this one you can rewrite this way. 1 over 2 square root x. Okay? Okay, what's the slope? Slope is y prime at x equals, when x equals how much? 4 here, right? Okay, put this number 4 there. That's the slope, okay? So 1 over 4, isn't it? Slope of this line equals to 1 over 4, right? Now we have a slope and a point, 4 and 1 already. Using this two, we can set up the equations. What is the equation of the line tangent? Y minus y1. Y minus y1 is 1 equals 1 fourth times x minus 4, right?
Yeah.
So maybe you can use a slope intercept form 1 over 4x minus 1 plus 1 plus 1 more over here, okay? That is equals to y equals 1 over 4x. Is okay?
Yeah.
Yeah, that's the equation actually pass through the what 0 over here, okay? This one. This is the correct one, okay? It looks like this. Yeah, this one. Using this one, we can find approximation numbers, approximation of these numbers at x equals 3.8. Just put this number into the equation, right?
Yeah.
Okay, what is the value of y? So approximation f of 3.8 This approximation value is about 1 over 4 times x is 3.8. That's right. Now we got what the height over here, right? A little greater than this number, okay? This number is about 9.6. No, 9.5, right? No.
Yeah.
0.9. That is less than 0.95. Okay?
Yeah.
But this one a little make big over here. That is actual value. This is actual value. This one is the approximation value. That is 9.95. Actual value square root 3.8 minus 1. I'm going to find this one. Okay, that is a little lower than this number. Okay,
Yeah.
I'm going to probe here. Oh, can you see the graph over here? Let me see. Okay, I'm going to you can see the graph now, right? So over here, square root 38 minus a. Okay, so I'm going to use square root 3.8 and minus 1. Outside minus 1, right? That is the actual value. 0.949. Are you okay with this?
Yeah.
Okay. This is 0.949. Actual value equals what? 0.949. But approximation a little greater this one. Just 0.001 higher, right?
Yeah.
Okay? This much, very small, right? This is a good approximation, right? Because 3.8 is very close to this number. Is it okay? So to find the approximation of some numbers, you need to find the equation of that linear line. Okay, this is a linear approximation. This we said what? Linear approximation. Okay.
Yeah.
Using the linear line. Okay, tangent line is linear. Linear approximation. Okay. Okay. Just to figure out this. This value is k, but we have an additional number too. The idea is that we better separate these two functions. Okay. Plus is always you can separate. Negative 2 e to the x squared dx, and plus also negative 2 and 2 dx. We separate. But this is already we got the numbers from the given. The integral value of this one is k. This is k plus. Okay, this is k plus. Oh, I'm sorry. This is negative 2, right? I'm sorry. This is from 0 to this is negative 2, okay? But check it out. E to the x squared is an even function, right?
Yeah.
Because f of x equals e to the x squared. F of negative x equals to still e to the negative x squared is what? Still e to the positive x squared, right?
Yeah.
So f of x, if f of x equals f of negative x, then f of x is even function, okay?
Yeah.
Even means what? Symmetry with in the y-axis, okay? So when x equals 0, what is that? Maybe you can find 1 over here, right? When x equals that is 1. When x is increased, that is increased this way. The other side also increased. That is even function, okay? So 0 to here, 0 to 2, this area is k. 0 to negative 2, also what? K, right? Is it okay? All right.
Yeah.
So this number is what? 2k, right? Or you can, this one is, we know that even functions, so you can check it out. Twice when you evaluate the integral from 0 to 2, that is twice, right? So this is k, so 2k, right? So we know that to the right is k, to the left another k, this is 2k, okay? 2k. Now take in antiderivative of 2. 2x is my antiderivative, right?
Yeah.
So we're going to take integral from negative 2 to 2. This number 2 in there 4, right?
Yeah.
I'm going to use only this one. This one first, okay. This one is 2. 4 minus 2 times negative 2 is what? Another negative 4, right? Is it okay? That is also 8, right? So this value is what? 2k plus 8. Are you okay with this?
Yeah.
All right, where is the answer? Over here. 2k plus 8, not this one. This is plus 2. Plus 8 is down there. Choice is the answer, okay?
Okay.
Okay, number 27 is a little hard. When you take a look over here, numerator is 2x plus 1, denominator is x squared plus 1. If we use u substitution, right? If you use u substitution, u equals what? X squared plus 1. But when you take a derivative, 2x dx, but we still have a plus 1 there, okay? But if you have a 2x dx is okay, but you still have additional plus 1, okay, we have to take care of this one. Is it okay?
Yeah.
That's why we need to separate this fraction, okay? Take a look over here. We cannot do this one, use substitution directly, okay? You have to use this one. 0 to 1, 2x over x squared plus 1. This is definitely we can use substitution, right?
Yeah.
Okay? This one is use substitution, we did already. And plus, the next one is what? 1 over x squared plus 1, right? Or you can separate, it doesn't matter, okay? Separate, it doesn't matter, same things. Okay. The first term will be u substitution, right? Take right, u over here. I'm gonna write down u equals x squared plus 1. du equals 2x dx. We already got 2x dx, okay, over here. 2x dx equals du. Okay, so x squared plus 1 is u. That is, now we replace this way. Okay?
Yeah.
But u value, x value equals 0. When x equals 0, y is 1, right? So when x is 1, 1 squared plus 1 is u is 2. We change all u value because this is a definite integral, okay? So we're going to evaluate this one. So this one is 1 over u and du, right?
Mm-hmm.
Are you okay this? Okay, now we're going to calculate this one. The next one over here. So we're going to find this one first. What is this? That's not equal, okay? What is this one? ln u, okay? This one is actually ln epsilon value of u integral from 1 and 2, right?
Yeah.
That is ln epsilon value of 2 is just 2, right? Because 2 is a positive. We're going to make always a positive, right? And the minus ln epsilon value of 1 is still ln 1. ln 1 is 0, okay? This is what? ln 2, isn't it?
Mm-hmm.
Now second term, take note the next one, this one. 0 to 1, 1 over 1 plus x squared. I'm going to switch, right, 1 plus x squared. Because this is the familiar form there. What is this one? What is antiderivative? Do you remember? Arctangent x derivative equals 1 over 1 plus x squared, okay?
Okay.
So this fraction, this function can be antiderivative will be arctangent x, okay? This is arctangent x. We take integral from 0 to 1. This is what? Arctangent 1 minus arctangent 0, okay?
Yes.
What is the value of arctangent 1? arctangent 1, this is the angle, okay? Theta angle equals arctangent 1, the equivalent, what is the equivalent form? Tangent theta equals 1, that's the mean, okay? Tangent theta equals 1. So this angle theta always between negative 90 to positive 90, okay? So 2b equals 1, tangent 45 always 1, isn't it? Tangent 45, right?
Yeah.
To understand, tangent 45 degree, 1 over 1, okay? Opposite over adjacent. So theta equals 45, but this one should be what? Radial mode, okay? Pi over 4, because this is a constant. The first one is pi over 4. Second one, take a look over here. Another one. Theta equals tangent negative 1, 0. Okay, tangent theta equals 0. Okay, tangent theta equals 0 is theta is 0. Okay, degree is 0. That is 0. Okay, so second one is 0. So total is how much? Pi over 4. Okay.
Yeah.
This is a little hard. The first integral is about ln2, second integral is about pi over 4, right?
Yeah.
So where is the answer? ln2 plus pi over 4, right? Choice A is the answer, okay?
Thank you.
You have the answer. You're going to add this to ln2 plus pi over 4, right? This is the value, this is ln2. This is pi over 4, okay? So this is a combination. Actually, this one is a combination of use substitution and inverse trigonometry, okay? Inverse trig function, okay? So inverse trig. Okay? So to memorize this one, okay? Arctangent x derivative equals 1 over 1 plus x squared, okay?
Yeah.
A little different form, okay? 2x, so compare this one. 2x over x squared plus 1. This is not this form, right? That is not arctangent, the antiderivative. This one, we have to use substitution, okay?
Yeah.
1 over 1 plus x squared antiderivative is what is the arctangent, okay?
Yeah.
Separate. Very similar, but this one is 2x, this one is we don't have any variable, okay? Okay, figure out the number 27, okay? I'll give you a minute, okay? All right. 28. The function g is the inverse of f. G is the inverse of f, right? This is original, this is inverse. This is inverse of f, okay? And the f is given by the equations. What is the value of inverse, okay? Derivative inverse at x equals negative 3, okay? That is what x value, okay? On inverse, inverse, okay? Maybe we can find it's inverse of f, but it is very hard to find, okay, inverse. This is y, okay? You switch x and y. Switch x and try this one. Y cubed plus 2y squared plus 6. Can you find inverse y equals? Impossible, right? Is it okay? Yeah. Or you can use this one as it is. That's fine too. You don't have to express y always. This is the inverse, but you need to take what? Derivative, right? What? That is a little hard. That's why we need to use a formula. You know the formula, right? For example, any example, this is the original f of x. This is g of x. If the inverse, they are always what? Symmetry in the y equal x, okay? This line. So there is a corresponding point. I'm going to find over g of 3 over here. That is 3. My x is minus 3. I'm going to use the y coordinate. I'm going to use k. Okay? This point, when x equals 3, y is k. Okay? what is its corresponding point of view? All the way down and perpendicular, right? To the other side, same with same distance. This is we set corresponding point. This corresponding point is a switch x and y, right?
Yeah.
X is coordinate k, y is -3. This is a corresponding point, okay? Because when you find the inverse, always we switch the value of x and y. That's right. But from here, what's the rule there? What is the rule? Do you remember? G prime -3 is equals to what? What's the formula? Reciprocal, right? Each
Yeah.
corresponding side f prime k, isn't it? The derivative of x equal k value, okay? Derivative of this slope. So derivative of x equal -3 of this slope. Actually, they are reciprocal each other. That's the rule, isn't it?
Yeah.
So to find this one directly, better find, okay, 1 over x prime k. That's right. That's the easiest way. Okay. Okay, now let's find the f prime k, but we don't know f prime k, value of k, we don't know. So value of y is -3. Using this one, we're gonna find the value of k there, okay? Okay, take it over here. Y is now -3, the original, okay? -3 equals negative square root k cubed plus 2k squared and plus 6. From here, we need to find the value of k, right?
Yeah.
Okay, minus is out. Now make squared both sides. 3 squared is 9. That is equals to k cubed plus, when you square over here, that is eliminate, okay? Square root is out. 2k squared and plus 6. Now solve this one. K cubed plus 2k squared and the minus 3 equals 0, right?
Mhm.
Yeah, this one is a little hard, but that is not a quadratic equation, right? That is not quadratic equation. That way it looks hard, okay? But this is a higher degree polynomial equation. This is called higher degree polynomial equations. To find the solutions, we have to apply, okay, possible, okay, rational zero test. You're gonna probably just try some numbers. One, beginning from 1, right? The factor of this one is what? 1, 3, only 2, okay? Now put this number 1 there. If that is 0, k equals what? Solution, right? Okay,
Yeah.
if k is 1, try this one. K is 1, 1 plus 2 minus 3 equals 0, right? Yeah, k is 1 is the solutions. Is it okay?
Yeah.
So where is the other factors? We already got the k is 1, okay? When you take a k is 1 there, up to right, okay? Using synthetic division, okay? 1, 2, k is no, and the constant 3, okay?
Mhm.
When k is 1 there. So 1 down, 1 times 1 is 1, okay? You're gonna add, right? 3. 1 times 3 is 3, you're gonna add a 3. 3 times 1 is 3, that is 0, right?
Mhm.
So this one can be factored what? K minus 1 and k squared minus 3k plus 3.
Yeah.
But we already got the k equal 1 there, okay? But this one cannot be what?
1.
Positive, okay? This one cannot be 0, right? Always a positive, okay? But this one is a little hard. Because when you take a derivative, okay, discriminant, okay, discriminant is what is that? B squared is 9 minus 4 times A is 1, C is 3, right? That is a negative number, isn't it? 9 minus 12, right? Negative is what? That means imaginary root. Imaginary root is what? This value always a positive, right? Because they never touch the right x value, okay?
Yeah.
So this value already positive. It can be 0, okay? Only k equals 1 there, okay? So from here we find why k equals 1 there. It's okay?
Yeah.
Okay, this one is the hard one, okay? That's why it is the number 28, okay? Okay, now take a derivative f of prime x. F of prime x derivative. This one is exactly equals what is that? Negative x cubed plus 2x squared plus 6 and to the 1 half, right? Exponent form. Put this number negative 1 half to the front. So negative 1 half still inside parentheses x cubed plus 2x squared plus 6 and the minus 1 half, right? Minus 1, right? After that we multiply, right? Derivative inside, okay, using the chain rule. 3x squared and plus 4 over x. That's it, right? So what is this one? So negative, okay? This is going to numerator. 3x squared plus 4x. This is going to denominator. Square root x cubed plus 2x squared and plus 6. And we still have a 2 there, okay? That's minus. That is derivative. This one is hard, okay? This is a hard one.
Okay.
Now put this number, where is x value? Over here, right? X coordinate is 1, isn't it? So we're gonna find the one over here. F of prime 1, right? That is equals to g prime over 3, right?
Yeah.
So f of prime 1 there. F of prime 1 there. Put this number x is 1. Numerator right there. 3 plus 4, right? 7. Are you okay with this? When x is 1, right? Denominator there, what is that? 1 plus 2 plus 6 is how much? Square root of 9, right?
Yeah.
Right, that is equals to negative 7 over, that is 3, right? 2 times 3 is, right? 6. Okay, negative 7 over 6 is the answer, okay?
Okay.
Let me see. Yeah, negative 7 over 6 is correct. The answer is what? This one. But this is not the answer, okay?
Yeah.
We'll fix it. A is the answer, okay? But this one is okay, I think, okay? So after class, okay, you try this one, okay? But not this time.
Oh.
Oops, this one, we did this one last time. Oh, it is not, okay, this is last times. That is number 76, okay? All right. We have a graph of f prime, that is the derivative function, okay? The graph of first derivative. Which of the following could be the graph of f? This is the graph of derivative. This is not original graph, okay? From here, we're gonna find the original graph, okay? Which is possible. It's gonna have, right, the same shape, okay? So maybe we can try this one graph, okay? Anyway, this one is some undefined one over here. Okay, vertical asymptote. Okay? Alright. Now check it out. Both sides is what? Positive anyway. They are both what? Increasing, right?
Yeah.
Is okay? But increasing, there are two different types. Concave or up increasing or concave down increasing.
Yeah.
How can you see that? Slope, right? Slope of this first prime is a second prime. When you take any point, this slope is what is it? Second prime positive, right? So in this section, from negative infinity up to these numbers, it's gonna be increasing but concave.
Oh, I'm down.
Yeah,
Trying to get down.
concave. This is positive is a concave up, right?
So be increasing and up still for the whole thing?
No, second derivative is increase. This is increasing, right? The graph of this one is a first derivative function, okay? This is the graph of f of prime x,
Okay.
not f of x, okay? So from here to here, the slope of this one is a positive. We already know that, all right? So concave up, increasing. Right after this, what happened? Anyway, over here, right, the differentiable, it's undefined, okay? Because that is discontinuity. The next one over here, increasing, but the slope is over here, what is that? Negative slope, right? Negative slope means f second prime x is less than 0, okay?
Yeah.
So second derivative is less than 0 means what? Concave, down, still increasing, right?
Yeah. Yeah, it's still be increasing all the way.
Still this is positive, right? Both sides increasing. So we're gonna make over here on the same page over here. From negative infinity over here. From this way, you can choose any point, okay? Because the initial point is not given. That is increasing, but concave up increasing, right? Concave up increasing how much? This way, right? It's okay?
Yeah.
The next one is a concave down increasing. Is it okay? Concave down increasing, what is that? Any point. You can use any point. Concave down increasing.
Yeah.
This one, is it? Left hand side looks like this one, right hand side looks like this one. Is it okay? Okay, this is not working, right? Right?
Yeah.
Choice A is not different, okay? It's different graph. Choice B, different graph too, right? The right hand side is what? Concave, down, increasing. This is what? Concave, okay? Up, decreasing, right? No, this is not working. Now, choice C over here. That the left hand side, concave up increasing. That's correct, right?
Yeah.
Right hand side is what? Concave down increasing, right? Yeah, this is okay, right?
Yeah.
Because the initial point is not given, right? That is the same shape. This is exactly the same shape.
Yeah.
Okay? This is also concave up increasing. This is concave down increasing. Still increasing, right?
Yeah.
But concave down increasing. Choice C is this, okay? But this is a concave down increasing, right? This is a concave down increasing. This is a concave down decreasing, concave down increasing, right?
Yeah.
This is a concave down decreasing. This one is concave up. No, still concave down increasing.
Okay.
That's right? Okay. This number 7, this is your bouquet, right? Okay. Now move on number 77 there. So we have a graph is given, okay? This is also what? Graph of first derivative.
First
Okay,
derivative.
first, not original, okay? First they give us what? Increasing this section, decreasing, increasing, but we can see another additional information. they are increasing with what? This is what second derivative, right? Slope is negative. Okay?
Yeah.
Second derivative going down is what that means. Concave down, increasing, right?
Yeah.
The graph is a concave down increasing. Looks like this graph. Okay, this is original. This is not. This is the only one. First derivative. Okay?
Mm.
So anyway, over here, okay, you can make a approximate, okay, original graph. The first from here to here, it's right, concave down increasing, right? That's fine.
Yeah.
Right up this one now decreasing with the slope is negative, right? Slope is negative means what? Second derivative is negative. Still negative, right? This is negative, this is also negative. Okay? So, concave down, decreasing, right? Primary decreasing, isn't it? Concave down, decreasing, up to here. Okay? Right up this one is what? Still decreasing, okay? Up to here, still decreasing, but how do they decrease it? Take a look here. Slope of this one positive, right? Second derivative is positive. Concave of decreasing. Are you okay with this? What is the concave of decreasing? Here, right? It's okay? That is decreasing, but the graph is concave up, right? So this point is my inflection point, right, over here. Can you see that? All right, the next one up here, still up here, we finished that. The next one still decreasing again. But how do they decrease? Slope is what? Negative again. Concave down decreasing, right? Concave down decreasing. Are you okay with this? You follow me? This is a negative means what? Decreasing, but it's a slope is a negative slope. It is concave down, right? Slope is negative means that second prime is less than 0, right? Concave down, decreasing. It's okay? So this is another right inflection point there, okay? They are charged concavity, right? This is positive is concave up, negative is concave down. After this up to 10, still what? Still what? Negative. Still decreasing. All the way we're going to decrease it. But this time decreasing, concave up decreasing, right? Concave up decreasing. Okay, so this is another inflection point. It's okay? Another inflection point. Now right after this, now increasing now, but how did they increase it? Slope is positive, right? Concave up, increasing up to here. Concave up, increasing. The next one is still increasing. That is a concave down increase, right? Concave down increase, right? This way. We finish this one. Also, there is an inflection point there, okay? Are you okay with this? So on what interval is the graph f is concave down? Where is the concave down? You can see it over here. Up to here, all the way concave down, isn't it?
Yeah. So starting down.
Yeah, because the slope of the graph is always negative, right? Concave down. This is concave up. This is also concave down again. This is concave up from here. That is concave down, right?
Yeah.
Which interval is the graph f is concave? Oh, I'm sorry, concave upward. Okay, up. It's not concave down. Concave up is what? Here and here, right? Concave up because their slope is positive. here concave up, right? Only two sections. So where is it? 2 and 5 first, okay? 2 and 5. Another one is over here. 8 and 10 over here, right? 8 and 10 concave up here. No, up to 11, right? Up to 11. Okay? They are concave up, right? Can you figure out? Just try to figure out, okay, find out the slope of this first derivative, okay? That means what? Derivative slope of first derivative is a second derivative, okay? But slope is what? Concave of is positive, right? That means the slope of this f prime x is positive, okay? Which graph has the slope is positive, you can check it out, okay? Okay, figure out this one again, okay? I'm gonna hold. The derivative of the function is given by here. And only for this intervals, on what interval of f is the graph? F is decreasing, okay? F is decreasing means our first derivative is less than 0, isn't it?
Yeah.
First derivative is less than 0, then decreasing, right? You have to solve this one. E to the 2 sine x and minus 1, this graph is less than 0. For what value of x that is less than 0? We have to make a graph, okay? Because this is what part 2, we need to use calculator, okay?
Yeah.
I'm going to show the calculator over here. First derivative is already given. That is y equals first derivative e to the y. E to the 2 sine x and minus 1. That's the graph. From where? 0 to 8 only, okay? I'm going to separate 0 to 8.
Yeah.
Like this one. That's the graph. We're going to find the decrease, right? That's the graph over here. From up to here. This is positive means well, up to here they are all increasing, right? From here to up to here, pi, they are always increasing. Are you okay with this?
Yeah.
Okay. This is not original, right? Not increasing, decreasing. This is derivative, right? So from 0 to pi, the original graph, okay? The original graph is just always all the way increasing. Are you okay with this, or okay? Pi 2 over here, what is this number? 2 pi. Between x equal pi to 2 pi, there is a minus v as well. In this intervals, the original graph is decreasing. That's the answer. From pi to 2 pi. Okay? Where is pi is what? 3.14. 2 pi is what? 6.28. Over here, right? Choice C there. Can you see that number? 3.14159. That is the value of what? Pi. 6.28 is what? The value of 2 pi, right? In this sections, that is decreasing. Are you okay with this?
Yeah.
Okay. So choice C is the answer, okay? I gotta careful. Sometimes we don't. It depends on teachers. Sometimes we don't including what the numbers, okay? But it doesn't matter, okay? Anyway, we gotta find the best answer, okay?
Yeah.
All right. So the graph is looks like I'm gonna okay. You can see the video, okay? All right. All right, number 79. Number 78 is okay. You have to use your calculator, okay? Use
Yeah.
your calculator and find out which sections. I'm going to show you this one more time, okay? When you make a graph of your, you got this one. Okay? All the way, this is a pi to 2 pi. From this side, the minus is all the way decreasing, right? From here to here, pi is to be increasing. Is it okay?
Yeah.
Okay. The graph looks like this one. That is the graph looks like this one, okay? Increasing, graph is increasing, okay? And increasing, and also all the way still increasing. High. After that, that is decreasing, okay? All the way down, decreasing. And increasing again, something like this one, okay?
Yeah.
All right, number 79. It's a recording, right? Let's check. It's a recording. Okay, we have a piecewise function. One is x squared when x is less than 2, x squared, and x is greater than or equal to, it is 4x minus 4.
Yeah.
X is 2 over here. X squared looks like this one, okay? 2 here, right? After the 4x minus 1, when x is 2, when x is 2, what is that? 4 times 2 minus 4 is the value of y is 4, right? So this
Yeah.
also 4 over here. You pass to this point, 4. It is continuous, right?
Yeah.
Is it okay? Put this number x is 2, that is 4. Okay, that is the limit value. But this number 2 there, that is 4. Limit value equal actual value, right? That is continuous, okay?
Mhm.
All right. When x is close to f of x exists. Is this correct?
Right. Yeah. It is. Wait. In
That is
my
the limit value, right? Limit value, yeah. That's it. To the left, the limit value is 2 over here, right? A 4, isn't it?
Mhm.
To the right, the limit value is still same 4, okay? That exists. It's okay, right? Limit value exists. From right hand side and from left hand side, they reach the same number, okay? F
Yeah.
over 2 is exist? Yes. F over 2 belongs over here, that is 4, isn't it?
Mhm.
F over 2 is belongs over here, equal sign, that is equals to 4, right? Yeah, that is actual value. This limit value also 4, right? Actual
Yeah.
value equals limit value, they are equal, that is continuous. So
Mhm.
f of x is continuous, x equal 2. Yeah, we already got, okay? Limit value.
Yeah.
Actually, actual value, that is what? Definition of continuous, right? So it will be easy the answer, okay? Can you figure out this one? Okay, just figure out one more time, okay? I'm gonna hold this one. Now the last question today, number 80, okay? Yeah, we have integral, two integrals there. F of x, the same functions, negative 2, 4, that area is 10, and the next one is what? 6 to 4, okay? Reverse way, right? From 6 to the left, okay? Which is 4. That is f of x equal to,
Mhm.
okay? So we're gonna find the from 0 to 8 there. We're gonna separate this one. From 0 to 8, f of x minus 2 dx, and the plus from 0 to 8, 1 dx. Okay, this value is what is that? 8, isn't it? Because
Yeah.
what? 1 is antiderivative is x. X to the what? The integral from 0 to 8 equals 8, isn't it? This value is 8. What is this value? We're going to find this value. 0 to 8. When you move right, this one, x to the, move to the left. Okay? but the boundary number say move to the left. Okay, what is this one? Check this one. If this is what? F of x dx, what that means?
F of x.
What is
So
it? It was
wait,
x
what's
minus
that?
2, now plus 2, right? When you have a plus 2, you get what? F of x, isn't it? What that means plus 2. Move to the left by 2, right?
Yeah.
Plus 2 means what? When you have this one. F of x minus 2 and plus 2. From here, plus 2 means what? Move to the left by 2. Move to the left by 2 is what? Okay, move this one also by 2. Minus 2, move to the left by 2, 6. Is it okay? This is actually what? Negative 2 to 6 over here, right? But this one is a little bit different. 4 down over here, 6 up here, that is a negative, right? F dx. Okay?
Okay.
It's okay, but this number is 2. This is 2, isn't it?
Yeah.
It's okay? So put this number minus the other side. The graph of this one negative 2, right? Actually. Are you okay with this?
Mhm.
So we got to stay over here. Negative 2 to 4 is 10, and the continue. 4 to 6 is negative 2. All together, put it together over here. Negative 2 to 6, f of x is how much? You can add these two, right? 10 plus minus 2 is how much? 8, isn't it?
Yeah.
Okay, that is 8. Okay. We still have another 8 there. Okay. This is 8. This is also 8. Total is how much? 8 plus 8 is 16. There, right? This is translate. So you have to use this translation, okay? Because they move right all together to the left. Okay? It's the same area when you have this graph. You're gonna find what the graph is what 0 to 8.
Mhm.
This graph, this area, right? But when you move this one to the what? Same thing. Minus 2 to 6. But this graph will move same graph. So this area is the same number, right? This is 8, this is also 8. Are you okay with this?
Yeah.
Alright, that's why okay by translations, okay, the area should be equal to what? 8. Okay, but you gotta be careful. 6 to 8 is what? 4 to 6 is gonna be negative sign, okay?
Yeah.
Alright, when you switch this 4 and 6, that is a negative 2.
So,
Okay?
right.
So all together is we continue over here, right? We continue over here from negative 2 and 4, that is 10. Continue 4 and 6 is what? Negative 2 means going down over here, okay?
Yeah.
That is a negative 2. That's the graph, okay?
Mhm.
So total is 8, right? 10 minus 2 is 8. But we still have another 8 over there, okay? So 8 plus 8 is 16 is the answer, okay?
Okay.
Okay, can you figure out this one?
Yeah.
Figure out one more time, so okay? I'll wait. If you figure out, okay, you'll let me know, okay?